So we're going straight into drill sheet 1. We went as far as question 10A. So we're doing question 10. Now we go to B. B is saying, remember question 10 is saying prove or disprove by counter, by counter example where possible. So now we proved A, we proved that the sum of two irrational numbers is irrational. We use the root 2 plus root 3. Then B is saying a sum of two irrational numbers. The sum of two irrational numbers is rational. So this is the same as A. So you can use the same example that we used in A and show that root 2 plus root 2 is not rational. It's actually irrational. Then we go to C. The product of two irrational numbers is irrational. The product of two irrational numbers is irrational. So what do we do? So for B, we are saying that the sum of two irrational numbers is rational. Here we show that the sum of two irrational numbers is irrational. So we used root 2 plus root 2 and did the proof, which ended up being irrational. So it means that statement 2 is not true. Okay, because we just showed that it is irrational. So it cannot be rational. So the conclusion of B is based on the conclusion for A. So the same sum, and then we saw that it was irrational, so it cannot be rational. Then C, we are talking of the product of two irrational numbers. Is irrational. Let's see. Let root 2 and root 3 be irrational numbers. Then you want to check the product. So say suppose that root 2 times root 3 is equal to A over B, where B is non-zero, A, B are integers, and A, B are coprime. Then we'll have what we have. If you're multiplying like this, remember, when you see root 2 is the same as you have seen 2 to the power half. And if you have AB to the power M, it's the same as you have A power M and B power M. So in the case of root 2 by root 2, and by root 3, this is the same as 2 to the half, 3 to the half. So it's the same as 2 by 3 to the power half, which is 6 to the power half, which is root 6. So this will mean that what we have is actually root 6 is equal to a over b. So that if we square here, we square on the right, we'll get if you square here on the right, we'll get 6 is equal to a squared over b squared. This implies that 6b squared is equal to a squared. Then we use the statements that a squared is divisible by 6, which implies that a is divisible by 6. So we can write a as 6k, where k is some integer numbers, which implies that if you get back to this guy, we can write it as 6b squared is equal to 6k squared, which is 6b squared is equal to 36k squared, giving us b squared is equal to 6k squared. This implies that b squared is divisible by 6, which in turn implies that b is divisible by 6. Then you say, hence, the contradiction. And so, root 2 multiplied by root 3 is irrational. So I've accepted that the product of two irrational numbers is irrational. So the reason why I was a bit fast when showing that root 6 is irrational is because we showed that root 2 is irrational. So the same way you show that root 2 is irrational, the same way you show that root 6 is irrational. So we're just multiplying. Where there is 2, now we're putting 6, 6, 6, and then seeing the effects of 6 throughout. This same example, this same question answers part D. Part D is saying the product of two irrational numbers is rational. But we just saw that in part C, root 2 by root 3 is irrational. So we have disproved using part C. So these questions cannot come at once. So you can pick one of these. If we pick D, then you get back to this and show in this same manner. When you reach here, you conclude it is irrational. So it's not rational. That's how you determine the same weighting. Okay, so let's go to question 11 now. We talk about complex numbers. Complex numbers lie on this guy here. I is equal to the square root of -1. This alone implies that I squared is equal to -1. So if you square I, you're squaring the root of -1, so you just get -1. So we see a pattern here. If you say I to the power 3, you'll be saying I squared multiplied by I, which is -1, multiplied by I, which is -I. If we do I to the power 4, you have I squared multiplied by I squared, but I squared is -1, I squared is -1, so you get +1. So if I do I5, then I have I4 multiplied by I. Because I4 is 1, so I'm multiplying by I, so you get I. If we say I100, then the best will be you divide 100 by 2 so that you keep 2 inside and then take 50 outside. Because we know that a to the power n and to the power m is the same as ANM. So now we have -1 inside to the power 50, which is equal to +1. If I have I to the power 105, the first thing you do is that you make the power even. So you say I power 104 multiplied by I. Because we know if the base is the same, AM multiplied by AN is the same as AM plus N. So we have I 104 plus 1, which is 105. But 104 now I can divide by 2, so we have I squared 52 as a power multiplied by I. I squared is -1 to the power 52 multiplied by I. This is 52, so -1 to the power 52, that's an even. So we get 1 multiplied by I, we get I. So like there's a question in the group where you're debating, which was I to the power 2n plus 1. Don't remember exactly. But if you have this, even if I don't know what you're supposed to show on the right, the key thing will be you get the left and work it out. So this is the same as I 2n multiplied by I to the power 1, which is I2 to the power n I. So you get -1 to the power n multiplied by I. This one, you leave it here until they tell you whether n is an even number or n is an odd number. Because if n is even, then we'll have I. If n is odd, then we have -I. So now I remember the question was I 4n plus 1. So you have I 4n multiplied by I. So you get I 4, then n I. I4 is +1 to the power n multiplied by I. So you end up just having I. So if the question says show that I power 4n plus 1 is equal to I, you start with the left hand side and say I 4n plus 1 is equal to I 4n multiplied by I. This is equal to I 4 in the brackets power n multiplied by I. But this is 1 to the power n multiplied by I. which is I, which is the right hand side. Where it becomes wrong is where you're taking the two at the same time. I 4 ni is equal to I. This implies that 1 ni is equal to I, which implies that I is equal to I. Then you say shown. This is not right. You pick one side, work it out until it gives you the other side. So now we go to question 11. What does question 11 say? Question 11. A. Express each of the following in the form A plus BI. So like A, so A will have 3 plus 2I multiplied by 2 minus 5I. This is equal to 3 times 2, we get 6. 3 times 5, we get negative 15I. 2 times 2, we get 4I. 2 times 5, negative 10. Then I times I, we get I squared. But this is 6 minus 11I. So 6 minus 11I minus 10 multiplied by negative 1. Okay, then you get 6, negative 10 multiplied by negative 1, you have plus 10 minus 11I. So you get 16 minus 11I in the required form. Someone is saying, I'll explain this. So we're saying if they ask you to prove this, you pick a side. Pick the left-hand side and get to the right-hand side by solving. If you pick the left-hand side, I to the power 4n plus 1. This is like you are dealing with m plus n is going to be am, an. So now our a is I, our m is 4n, plus our n is 1. This is going to be I 4n multiplied by I 1. So that you have now I 4 inside, n outside. To the power, then multiplied by I. But you know that I to the power 4 is 1 to the power n multiplied by I. 1 to n power is 1. 1 times I. So we start with our left-hand side of n to the right-hand side. So that becomes the solution. So that's how it becomes easy here. Once you're able to pick a side, you simplify. The key thing is just knowing these rules of indices. If I have m plus n, it's the same as am, an. So I for n plus 1 is I for n, I. For n, you get here. You can separate these. Nm is the same as nm. So if I have this side, I can write it in this form. So we have I for n, I, it's the same as I for n outside, then I. But I for is 1. So 1 to the power n I, 1 to the power n is just 1. Multiplied by I, you get I. Okay. B, 1 plus root 2i over root 3 minus 2i. When you have a fraction, you conjugate the denominator to get rid of the I from the denominator. So this is going to be the same as 1 plus root 2i. You multiply by the denominator, you change the sign of the imaginary number. So you multiply by 2i, divide by root 3 minus 2i, multiplied by root 3 plus 2i. So we get 1 times root 3, we get root 3. 1 times 2i, we get 2i. Root 2 times root 2, we get root 6i. Root 2 times 2, we get 2 root 2. So put plus I times I, we have I squared. Over root 3 times root 3, we get 3. Root 3 times 2, we get 2 root 3. I, 2 times root 3, we get minus 2 root 3i. And then 2 times 2, we'll have negative 4 there because the other 2 is negative. Then I times I, we get I squared. Then we simplify. So we'll have root 3. I squared is negative. So negative 2 root 2 plus 2i plus root 6i over this minus this one, we get 0. So we'll have 3. I squared is negative. So negative times negative there, we get positive 4. So now put the real parts together over the denominator plus the imaginary part together over the denominator. So the real part, root 3 minus 2 root 2 over 7 plus 2 plus root 6 I over 7. So you are conjugating at the same time rationalizing. It's a nice question. Then C, we have 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i. Okay, so you get, if you want, you conjugate separately and then put them together, or you multiply around. You get the common denominator and get the numerator, then you conjugate. So let's conjugate separately. So 1 plus 2i multiplied by 1 plus I over 1 minus I multiplied by 1 plus I plus 1 minus 2i multiplied by 1 minus 3i over 1 plus 3i multiplied by 1 minus 3i. So we're conjugating each piece. This one we conjugate alone, this one we conjugate alone. So get 1 plus I. We're expanding now the numerator for the first one. Plus 2i minus 2 over 1 plus I minus I plus 1. So when I say plus 1, because we are having negative I times I, which is negative 1. And then plus 1 times 1 multiplied by 1 times negative 3i multiplied by negative 2i. Negative times negative plus. I times I, negative. 2 times 3, 6. Over 1 times 1, 1. 1 times negative 3, negative 3i. 3 times 1, positive 3i. I times I, negative. Negative times negative, we get positive 9. This is implying that we have 1 minus 2, that is negative 1, plus 3i over 2, plus 1 minus 6, we get negative 5, minus 5i over 10. Then here now, the common denominator is 2 actually. We can keep this over 2 plus, if we divide by 5 throughout, I will have negative 1 minus I over 2. Okay, what's happened? My network looks very stable. How many are unable to see the So I think it's the network that is tripping. Okay, so if we put 2 as a common denominator, then we'll get negative 1 plus 3i and then plus negative 1 minus I. So this is, so here I'm supposed to be using equal sign, not implies. Because these are equal. So equal, 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 equal. Negative 1 minus 1, we'll get negative 2, and then 3i minus I, we get negative 2i. Then you separate the 2, separate the 2. So end up having negative 1 minus I, like this. Okay. Then okay, so we can start all together. We are now about to go to question 12. So log out and quickly log back. So that we go to question 12. So we're logging out, then we keep log back.